to our video. Today I will tell you about OCI and TCP/IP model.
And I will explain to you the network architecture.
We hope you enjoy our video. Let's go!
Today I want to tell you about a very important thing, OCI model. Why is it important? It's simple. It fully describes how network devices work and is absolutely essential to understanding how computer networks work. And yes, no interviews are required without questions about the OCI model. So, if you want to become a network engineer and have an IT industry salary, you definitely need to understand it. So, what is it? In simple terms, this is the process of transferring data which was divided into 7 layers, each of which is responsible for performing a specific function. Physical layer. At the first layer of the OCI model, physical signals, currents, light, radio, are transmitted from the source to the receiver. At this level, we operate with cables, contacts and connectors, coding of ones and zeros, modulation, and so on. And the next layer, the data link layer. The data link layer encompasses 2 sub-layers of its own. The first, media access control, provides flow control and multiplexing for device transmissions over a network. The second, the logical link control, provides flow and error control over the physical medium as well as identifies line protocols. Network layer. The network layer finds the destination by using logical addresses such as IP, Internet Protocol. At this layer, routers, a crucial component used to quite literally route information where it needs to go between networks. Transport layer. The transport layer manages the delivery and error checking of data packets. It regulates the site sequencing and ultimately the transfer of data between systems and hosts. One of the most common examples of the transport layer is TCP, or the Transmission Control Protocol. And the next layer, session layer. The session layer controls the conversation between different computers. A session or connection between machines is set up, managed, and terminated at layer 5. Session layer services also include authentication and reconnection. Presentation layer. At the 6th layer, the conversion of message formats such as encoding or compression is done. For example, JPEG and GIF. The layer is also responsible for transferring the stream to the 4th transport layer. On the 7th layer, at the very tip of the iceberg, is the application layer. At this layer, both the end user and the application layer interact directly with the software application. This layer sees network services provided to end user applications such as a web browser or Office 365. The application layer identifies communication partners, resource availability, and synchronizes communication. What is a TCP/IP model? It's a model to standardize computer networking. The OCI model, while widely referenced, isn't used in the real world. The TCP/IP model, however, is the real deal. Thankfully, it's not all that different. It contains 4 layers, unlike 7 layers in the OCI model. The layers are application, transport, internet, and network interface. Application layer interacts with software application to implement a communication component. The interpretation of data by the application program is always outside the scope of the OCI model. Example of the application layer is an application such as file transfer, email, remote login, etc. Transport layer. Transport layer helps you to control the reliability of a link through flow control, error control, and segmentation or desegmentation. It divides the message received from the session layer into segments and numbers them to make a sequence. Transport layer makes sure that the message is delivered to the correct process on the destination machine. It also makes sure that the entire message arrives without any error, also it should be retransmitted. Internet layer. An internet layer is the second layer of TCP/IP layers of the TCP/IP model. It is also known as the network layer. The main work of this layer is to send the packets from any network and any computer till they reach the destination irrespective of the route they take. Network interface layer. Network interface layer is this layer of the four-layer TCP/IP model. This layer is also called a network access layer. It helps you to define the details of how data should be sent using the network. It also includes how bits should optically be signaled by hardware devices which directly interfaces with a network medium like coaxial, optical, fiber, or twisted pair cables.
And I will tell you about a very interesting topic. This is the network architecture. What is it? Network architecture is a very broad concept that includes quite a lot of sections and definitions. It can be related to both the construction of networks and their design. So, network architecture refers to organization and allocation of tasks between the computers in a system. Since network architecture is a very broad topic, there is not enough time to talk about everything. So I will tell you about the two most widely used architectural models. The first one is a peer-to-peer network or P2P network. In P2P network, all computers connected have equal capability and the capacity to use the resources available on the network. A peer-to-peer network is considered robust as if one or several nodes stop working, the network continues to function. It is mostly used for file sharing. One of the earliest peer-to-peer file sharing networks was Napster, and the recent protocol is BitTorrent. The second is client-server network. In this network, a number of network clients or workstations are connected to a main computer known as server. There can be more than one server. Client-server networks are used in cases where many users need to be connected to the network and the P2P network capabilities may not be sufficient. Then a specialized server computer is connected to the network. And the client-server network is also used by desktop programs that transmit data over the internet. This is the end. Thank you for watching. Goodbye.